चलो ठीक है ये. This is just a quick recap. Where did we? What was the last thing that we did? Okay, so basically we just did water was ionizing. It was producing H plus one and OH ions. Okay, that's what it's doing. And based on that, there is an equilibrium constant, which is known as the water constant. It's the product concentration divided by the reactant concentration, except that the reactant is in large excess, which means it's going to be taken as a constant. So your K equilibrium was product concentration divided by the reactant concentration, and since water was a constant, your Kw was basically H plus 1 times OH minus 1, or you can say H3O plus 1 times OH minus 1. That was your ionic product of water. And so that was your ionic product of water, and it had a value. Pure water had it ionized very little. Pure water, it barely had any H plus 1 or OH ions. It had very few H plus 1 and OH ions. So 1 times 10 to the power minus 7 mole per dm cube, and this was also 1 times 10 to the power minus 7 mole per dm cube. So your ionic product of water, if you multiplied the two concentrations, that would come out to be equal to 1 times 10 to the power minus 14. Okay? This multiplied by this, and that gives you 1 times 10 to the power minus 14. This is the unit for Kw. And remember, Kw is a constant at all temperatures. Except that the ionization increases. If you increase temperature, the ionization of water would increase. So which means that यहाँ पे add कर लेते हैं, hence Kw also increases. ठीक है? So this was the ionic product of water, and I told you that it's always going to be a constant for any types of water. ठीक है? Only temperature is the only thing that changes this value. So what happens is that if you have pure water, okay, three types of water. You've got neutral water, right? Now in neutral water, the H plus 1 and the OH ion concentration is going to be exactly the same. It's going to ionize, and it's going to be exactly the same. Or second type was that you had your water could be acidic, which basically means you've added an acid to water. In that case, what happened was H plus 1 concentration is going to be higher, and your OH ion concentration is going to be a lot lower. Okay? Acidic, if you add acid to water, all the OH ions are going to get neutralized, so there's going to be very little OH ions, and the H plus 1 concentration would be higher. Acid hota kya hai? What is an acid? It's a proton donor, right? It's a proton or an H plus 1 donor. But the product of the concentrations would still be equal to 1 times 10 power minus 14. That's going to be a constant. इसमें pure water के अंदर they're both equal, but the product is still going to be 1 times 10 power minus 14. And the last one was that you're going to have alkaline water. So alkali base क्या होती है? That's a proton acceptor, or an H plus 1. So it's going to reduce the amount of H plus 1 in water. So in that case, what would happen is H plus 1 is going to be a lot lower in concentration if the solution is alkaline, and the OH ions are going to be a lot higher. Okay, but the product of the concentrations, that's still going to be 1 times 10 power minus 14. Okay. And so now the thing is, and you have a pH scale that basically tells you this. So now the thing is, the type of water that you have, your water could be, so you're going to have three types of waters. Your water could be neutral, or it could be acidic, or the solution could be alkaline as well. So you've got three types of waters. Now this is very important because every reaction has, because all reactions are happening in water. You get most reactions, not all, but most reactions, most of these particles are floating in water. So most reactions are going on happening in water. And the H plus one and the OH ion concentration, the balance between the two, affects the reactions. So, so reactions are very sensitive to the pH in which they're happening. Plants are not going to grow if they don't have the right pH. Your stomach is not going to work properly. Your enzymes are not going to work properly if the pH is not the right. So reactions are very sensitive to pH. अच्छा तो hopefully ये बात clear है कि what is the KW, that's always a constant, right? That's not going to change unless you change temperature. And reactions are very, very sensitive to the balance between the two. Okay, so whenever reactions are happening, you always have to check what type of water you've got. Okay, that's very important. And that is determined by the pH scale. Okay, so you have a pH scale, and that determines how the concentration of the ions is varying in water, right? I said now we're going to move to the pH scale. What is a pH scale? Yeah, this time we're going to do this in detail. Now, the ionic product of water was the concentration of H plus 1 times the concentration of OH ions, right? And it had a particular value, which was 1 times 10 power minus 14. We've written this many times. Mole square Dm minus 6. Okay, so we have this. Now, this H plus 1 concentration could be, I mean, it could be very high. It could be, I say it could be very high. It could be very low as well. So it could be, let's say it could be high as well. It could be 0.1 mole per dm cube. That means the water is very, very acidic. If the water is alkaline, that means it's not going to have a lot of H plus one ions, right? So that means the concentration could be extremely low as well. And for example, just to give you an example, uh, your your stomach, the water that's in your stomach, that's got a very high concentration of H plus one ions, but sometimes your saliva could be very, very basic as well. Okay, so that could have a very low pH as well. The H plus one concentrations can be very low. So the trouble is, okay, it's very hard to plot. I mean, a lot of times you have to plot how the concentrations are varying, right? Because a lot of things depends on that. Okay, for example, you've got soil and you want to plant trees or plant crops on it. So throughout the year, you want to test how the H plus one and OH concentration varies over time. So plotting these two values on a piece of graph paper, that's very difficult because one value is like relatively bigger and the other value is relatively very, very small. So science fair, a lot of times what happens is that you've got very big values, you've got very small values, and you have to plot them on the same piece of graph paper. So instead, what they do is, because plotting decimals and values that are very, very small, because plotting them on a piece of graph paper is so difficult, that they don't actually use these values. What they do is they use the logarithmic scale, which is they express these values in the powers of 10. Okay, this is 10 power minus 1, or ye kya hoga? What is this? The other one, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 10 power minus, I think that's 10 power minus 11, right? So instead of plotting these numbers, what they do is they go into the log scale. What log does is, it's a button on your calculator. It expresses the powers in 10. This is 10 power minus 1. So it's log is going to give you minus 1. The other one is 10 power minus 11. Log would give you minus 11. Now, plotting 1 and 11 on a piece of graph paper is very easy. Plotting 0.1 and and a very, very tiny value on a piece of graph paper, that's very, very difficult. Okay? So the point is just for the sake of, because remember, science के अंदर ना सबसे important जो चीज़ है in any field, it's data visualization as well. Okay? You can't visualize these two values relatively because you can't plot them on the same piece of graph paper, but plotting 1, -1, and -11, you can plot them easily and you can visualize this. Okay? So this is what your log scale would give you. Okay? So idea clear है कि why we are moving towards the log scale? Is that clear, Middle, Umar, Hala, Rumesa? Is this clear that why log scale is important?
Yes, sir.
ठीक है?
Yes, sir.
अच्छा, so point is, this KW expression is turned into the log scale. ठीक है? All of it is turned into the log scale. तो यहाँ पे मैं ऐड कर लेता हूँ log helps you plot better graphs. Actually, log के साथ ना what you can do is you can plot a graph and you can have the world's biggest number and the world's smallest number on the same piece of graph paper. Here, for example, you can plot 10 to the power 25 and 10 power minus 25 on the same piece of graph paper. Because in log, this is going to be 25 and the other one would be minus 25. So, that could be easily done. So that's the good thing about log, that you can plot very big, very small values on the same graph paper. Okay? Anyway, so this one is turned into the log scale. So log is taken on both sides. So it's log of KW and log of H plus 1 times the concentration of H plus 1 times the concentration of OH ions, right? Achha, one thing about log is that in log scale, multiplication becomes addition. Like if I multiply two numbers, 10 power 3 and I multiply it by 10 power 7. Okay, so I'm multiplying two numbers, right? Now, in log scale, it's actually going to be addition. The powers of 10, 3. I mean, log value would be 3. The log value for this would be 7. And the log value for the final answer is going to be 10. So in log, the powers are getting added up, right? So, multiplication in log is actually addition. So what's going to happen is you're going to have log of KW equal to log of H plus 1 concentration. And the multiplication would become, in terms of log, it's going to become addition. ठीक है, तो ये फिर से मैं clear करूं कि the actual numbers were getting multiplied and you were getting this, right? But in the log expresses the values in powers of 10. So log 10 power 3 is 3. Log 10 power 7 is 7. Log 10 power 10 is actually, it's obviously going to be 10. So that's going to be addition in log. Okay. So H plus 1 concentration times OH concentration in log is addition. So you get this new expression, which is this one. And I'm going to multiply both sides by a negative sign. Yeah, I just multiplied both sides by -1. And I'm going to tell you the reason for that. Minus से क्यों multiply कर रहे हैं? Remember this. I mean, the purpose of the log scale is to basically plot a graph. Concentration is a number that's usually in decimals. But a 1000 mole per dm cube is you're never going to witness 1000 mole per dm cube. So concentration is a number that's usually in decimals. You're going to have a low concentration, you're going to have a high concentration. 10 mole per dm cube bhi bada rare hai, theek hai? So it's usually in decimals. So if it's in decimals, so you take the log scale, what do you get? It's 10 power minus 1 and this is 10 power minus 11. So you're getting negative numbers. So the point is, since you're dealing with concentrations, every time you're getting negative numbers, so it's kind of going to be pointless to plot a graph of negative numbers. तो आप क्या करो, simply उसको multiply by -1 कर लो. So what happens is if you multiply all of them by -1, they all become positive. I mean, it's just you're just multiplying it both sides by -1 so that the numbers actually become positive numbers. Because if you are to plot a graph, it is better, because at the end of the day, you're going to plot a graph. So it's going to be a lot easier to plot a graph of positive numbers. ये भी clear है? Is this thing clear? Clear है?
Yeah.
Umar, Minal, is this clear?
Yes.
हाँ. अच्छा, to get positive numbers, right? But that is going to lead to a problem. And the problem is that it's going to invert the log scale. पहले क्या था कि if you hadn't multiplied it by -1, this was actually a higher concentration. -1 was actually the bigger number, right? This was a smaller concentration. -11 was actually a smaller number, right? Achha, so -1 was actually bigger than -11, right? Achha, lekin once you multiplied it by -1 on both sides, so actually now what happens is that when you multiply anything by minus, right, the smaller becomes the bigger number becomes the smaller number. So what happened was, कि अब जो 11 है ना, that's actually the bigger number. So that means a lower concentration, because you're multiplying it by -1, would actually give you a bigger number. So log इसलिए उल्टा होता है. वो जो pH scale है ना, a higher value means, मतलब pH में acidic में क्या होता है? If you have a lower number, that means it's more acidic, right? So the reason the log scale is actually the other way around is that the smaller number means higher concentration of an acid, right? It's because of this you multiplied the expression by -1 so that you stop getting negative numbers. That's it. Or negative numbers are multiply करने के लिए, the bigger number becomes the smaller number. ये भी clear है कि why -1 does this? Is this clear?
Yes.
Achha, so just to simplify everything, we had your KW expression. Okay, I told you that log was something that was better at or more useful at plotting graphs. So we took the log on both sides. Okay, when we took the log of KW and log of H plus 1 in log, multiplication becomes addition. Okay, that's a property of log. वो मैंने यहाँ पे show भी कर लिया कि the powers are getting added up. So you're multiplying numbers, the powers are going to get added up. So we got this thing, and I multiplied it by -1 so that when I input concentration, I don't deal with negative numbers. I just deal with positive numbers. अच्छा, अब final चीज है कि that's your other expression. अच्छा, both of these expressions are exactly the same. You've got this expression and you have this expression. They're exactly the same. अच्छा, value भी ले लेते हैं. What's log of this? That's going to be -14, right? So the answer to this is, अच्छा, so this is going to be equal to 14. ठीक है, वो ऊपर देख लो कि if I take log, this is going to give me -14. But since I'm multiplying it by a negative number, I'm going to get 14. तो वो negative से ना your जान छूट गई, ठीक है? You don't have to deal with negative. So anyways, we've got this expression. Both of these expressions are exactly the same, except one of them is the log expression. So now coming to the final thing. This thing, this entire thing, minus log of H plus 1. This is called pH. जो सारी जिंदगी pH पढ़ते आए हो ना, this is pH. And minus log of OH ions, that is called pOH. And that's equal to 14. Okay? So remember, pH is what? pH is the negative log of the concentration of H plus 1 ions. And what is pOH? That's the negative log of concentration of OH ions. Okay? Now, normally what happens is you never really hear about pOH. No one talks about pOH because it's kind of easier to just track one thing. Because the other thing is exactly the opposite. Like if you know what's happening to H plus 1, like for example, the H plus 1 concentration is going up, then by default the OH ion concentration would be going down, right? So that is understood. If H plus 1 concentration is going down, that means the OH ion concentration is going up. So you don't really have to track both of them, although that is equally important. But you can only track one of them, okay? Which is why you normally just track pH. You don't really talk about pOH. You've never heard about pOH. But pOH is equally valid. Okay? If you want to, you can start tracking pOH and you can ignore pH. But that information would be, I mean, it's kind of complementary. Okay? If pH is higher, the pOH is going to be lower. If pH is lower, the pOH is going to be higher. Okay? So remember this expression. So अभी दो expressions हो गए. One is Kw, which was this one, the first one. 1 times 10 power minus 14. Then you had the log expression, which was minus log Kw. And that log expression could be written as pH plus pOH is equal to 14. Okay? Is this thing clear?
Yes.
So, अच्छा अब ये कि सारों को clear है, ऊपर clear है, हाला और मैसा, is this clear?
Yes, sir.
अच्छा, so
Yes, sir.
ठीक है. So what we'll do now is we'll first talk about strong acids. Strong acids are, I mean, they're calculating their pH. You can remember what is pH? Just calculator pe na, there's a button, negative log of the concentration of H plus 1. You would need a calculator to do this. So for strong acids, it's pretty easy. They fully dissociate or fully ionize. So for example, if I have HCl and the HCl is 0.01 mole per dm cube, the strong acid is going to fully ionize. So it's going to fully break down, dissociate, and it will produce H plus 1 and Cl minus 1 ions. So since it's fully dissociating, this is also going to be 0.01 mole per dm cube. And this is also going to be 0.01 mole per dm cube, right? So strong acids is easy. You can figure out the pH, not the pH, the H plus 1 concentration very easily. That's 0.01 mole per dm. You don't have to do any special calculations for that. I say now HCl is obviously aqueous. There's water present as well. But what you're going to do is you're going to ignore water. Because water would also be producing some H plus 1 ions, right? Why are you going to ignore water? Because earlier we did discuss that the concentration of H plus 1 ions that are being produced by water, that's very, very low. ठीक है, ये ऊपर आएगा एक second. So that is extremely low. So I mean, even if you So the amount of H+1 that's coming from water, that's kind of negligible. So water ionizes weakly. So H+1 concentration from water can be ignored. I mean, it could be ignored. Achha, but ये सारे aqueous हैं, ठीक है? So remember, everything is happening in water. We're going to use the same Kw. So I'm going to use both expressions. वो क्या expression था? Kw stands, it's 1 times 10 power minus 1 minus कितना है? 14. So it's H+1 concentration times what? OH ion concentration. Kw was what? 1 times 10 power minus 14, right? What is H+1 concentration at the moment? That's 0.01. Plus, there might be some H+1 coming from water as well, but that would be so small कि वो 0.01 में ऐड करने का ना उसका कोई point नहीं है. ठीक है, so you can simply ignore that. अच्छा, times the OH ion concentration. So the point is, we know the H+1 concentration. We don't know what the OH ion concentration is, which can be found out in the expression. And if I find this out, it's OH minus 1 concentration, and that's equal to 0.01. 0.01 10 की powers में क्या होता है? That's 10 power minus 2. Sorry, it's 1 times 10 power minus 14 divided by 10 power minus 2, and that's going to give me 10 power minus 12. Okay. So is this idea clear that if you know the H+1 concentration, you can also figure out the OH ion concentration as well in the solution. Is this clear?
Yes.
Clear. Achha, but the point is, a lot of times we're not really interested in, I mean, normally questions are not going to be interested in the OH ion concentration. ठीक है, वो complementary, it's under, most of them would be tracking H+1. Achha, anyways, what if they ask you to calculate the pH of the solution? So how was pH calculated? It was minus log of the concentration of H+1 ions. And we do know what H+1 concentration is, that's 0.01. And there's a tiny, very tiny amount coming from water as well. So that's going to be minus log of, what is H+1 concentration? That's 0.01. If you do this on your calculator, what do you get? Well, the log mein kya hoga? That's, I mean, although this one can be done mentally as well. 0.01 is 10 power minus 2. So you're going to get minus 2, and since there's a negative sign, you're going to get a pH of 2. Okay, is this clear? और अगर calculator पे करना है ना, remember log is a button on your calculator, and you just have to press that button. And you have to get rid of the negative sign, basically. उसका sign उल्टा कर देना, ठीक है, minus. Just make the sign the opposite. So the pH of this solution is going to be 2. ठीक है, सारों को clear है? Rumesa, Umar, Hala, Minal, is this clear?
Yes, sir. Yes, sir.
So ठीक है, so strong acids, calculating the pH of strong acids is easy because they fully ionize or dissociate, so you would be able to figure out the concentration of H+1 ions directly. And all you have to do is you just take the log scale of that and you get the pH or the negative log of that. Okay. Or agar kisi ne, if somebody is going to ask you about the OH ion concentration, you can plug in this. I mean, there are actually two ways of doing that. Agar pH pata lag gaya na, so you can use the other expression as well, which was what? It was pH plus POH is equal to 14, right? So two expressions then. One was the original one, and the other one was the log expression, which was this one. So anyways, we know what pH is. The pH is 2. We don't know what POH is. And we know that it total होना चाहिए, that should be equal to 14, right? So my POH would come out to be 12. Now, what was POH? POH, ये ऊपर लिखा था, POH was actually negative log of the concentration of OH ions. So POH was minus log of the concentration of OH ions. That's equal to 12. वो minus इधर से खत्म कर लो तो that's minus 12 log of OH. How do you get rid of the log? उसको वापस power बना दो. So you want to get rid of the log, you take the inverse log. So OH ion concentration would be 10 to the power minus 12. ठीक है, ये ऊपर भी यही आया था, which is this one, 10 to the power minus 12. ठीक है, so remember, you want to take the inverse of log, take that number, make it the power back again. इसको थोड़ा सा practice भी कर लो. Okay, let's say you have log of 10 power, let's say 8. So the answer is going to be 8. Now, if you want to take the inverse log, calculator में inverse log जो होता है ना 10 power x होता है. Inverse log is actually 10 power x. मतलब वो 8 है ना उसको. So if you want to take the anti-log कहते हैं inverse log, ठीक है? Anti-log कहते हैं मेरे ख्याल से. अच्छा, calculator में anti-log is 10 power 6, 10 power x. ठीक है, इधर 10 power 6 तो नहीं, 10 power 8 है, ठीक है? अच्छा, you want to take the anti-log of 8. What you're going to do, you're going to make it 10 power 8. वापस आ जाओगे, ठीक है? So that's what anti-log is. तो OH ion concentration, तो ये दो चीजें ना, दो functions आपको बार-बार use करने पड़ेंगे, ठीक है? Remember, log is, just press the log button on the calculator and it's going to give you the answer. It's going to express the number in the powers of 10. You want to take the inverse log, तो वही नंबर उठाओ, उसको 10 पर x कर दो या उसको बेसिकली पावर बना दो, ठीक है? तो एक और कर लेते हैं, let's do one more, ठीक है? Because this requires some practice, ठीक है? Because you're for a lot of you don't know what log is. So let's go for a base. I've got a base and the concentration of the base is 0.0001 mole per dm cube. And it's a strong base. Okay, this one is a strong base. Achha, what's going to happen is since it's a strong base, it will fully dissociate. It's going to produce Na+1 and it's going to produce OH ions. Now this is 0.0001 mole per dm cube. So the amount of OH ions that it will produce, it's going to be 0.0001 mole per dm cube as well. It's a strong base. Achha, अब यहाँ पे उल्टा है because there is no H+1, although there is H+1 in water. So you're going to use the Kw expression. Now you know what Kw is, 1 times 10 power minus 14. You don't know what H+1 is, so that is unknown. But you know what OH ions is. That's इसको 10 power minus 4 कहते हैं. I think it's 10 power minus 4, right? So what is the concentration of H+1? That's going to come out to be 10 power minus. Well, उसको कर लो, divide कर लो, 1 times 10 power minus 14 divided by 10 power minus 4, and that's going to give you 10 power minus 10. Now, if I take the pH now, pH क्या होता है? It's the negative log of the concentration of H+1. So log would have been minus 10, negative log would have been plus 10. So pH 10 आ रहा है. ठीक है? So what I did was, even though it's a base, because everyone is tracking pH, they're not tracking pOH. pOH is equally valid, but no one likes pOH. Okay? So I had OH ion concentration. So I used that OH ion concentration, which is solution, and I was able to figure out the H+1 concentration. The OH ion concentration went up, the H+1 concentration would have gone down. And I was able to figure out the H+1 concentration, which was 10 power minus 10. And I took the anti-log of that. Oh, sorry, not the anti-log. I took the log of that, the negative log, and I got 10. So इस solution का जो pH है ना, that's 10, right? The other way I could have done was I could have पहले से ही log में, उधर मैं end पे log में गया, मैं शुरू में log में चला था. I could have calculated pH. That's the negative log of this thing. And that would have given me this value. क्या value होती है? It's -4 and a 4 आ जाता. I mean, this is 10 power minus 4. So if I take the log, it's going to give me -4. And if I multiply it with -1, that's going to give me 4. So I got the pOH. फिर मैं वो जो pH plus pOH वाला expression है ना, उसके अंदर add कर देता. That's equal to 14. So my pH would have been 4 is equal to 14. And my pH would have come out to be equal to 10. Okay. So remember this. You can either use this expression or you can either use the KW expression. They're both exactly the same expression, except कि उसमें इसके अंदर ना मैं log में end पे गया हूँ, ठीक है? I did the log function at the end. In the pH plus pOH, I started off with the log function, so my end result is automatically in log. ठीक है? तो इसकी खैर we will practice this a lot. लेकिन यहाँ तक clear है इसकी. Remember we're going to practice this again in the next class. But is this clear?
Yes.
तो और ये आगे ना पीएच और पीओएच इसी की कहानी चलती रहेगी. तो ये तो फिर वो बहुत ज़्यादा प्रैक्टिस करना पड़ेगा. फिर नेक्स्ट क्लास में हम करते हैं. ठीक है, चले. ओके एवरीवन, टेक केयर.